All right, you guys ready for the evens? 118 is the first even. Where the heck is it? There it is. So the answer for the acceleration is -10. The answer for the position is -5 t squared plus 50t. That was 118. 122 is the next even. Part A, the position as a function of time is bt cubed over 6 plus v0t plus x0. In part B, the position at 5 seconds is 62.5 meters, and the velocity at 5 seconds is 37.5 meters per second. And 124, part A. The velocity as a function of time is a0t plus bt squared over 2 plus v0. They don't have to be in that order. You know, you could do bt squared over 2 plus a0t plus v0. That's fine. In part B, the position as a function of time is a0t squared over 2 plus bt cubed over 6 plus v0t plus x0. And in part C, the average velocity is a0t over 2 plus bt squared over 6 plus v0. And that's the end of the assignment. All right. Anything you guys want to go over on this assignment? Yes. I'm sorry, I can't hear you. 124. Okay. So in problem 124, it says, consider the motion of a particle that experiences a non-constant acceleration a, given by a equals a0 plus bt, where a0 and b are constants. Part A wants the instantaneous velocity as a function of time. Okay, so to get your velocity as a function of time from an acceleration, what you're going to do is the integral of the acceleration with respect to time. Right? Are you with me so far? You know that's the physics piece. Now we'll tackle the calculus. Can we do the calculus? So we're going to integrate a0 plus bt with respect to t. I'm going to rewrite that so it looks like the integral of a0 times t to the 0 power plus b times t to the first power with respect to t. And I'm also then going to rewrite it to distribute the integral and the dt to both terms. So that would be the integral of a0 t to the 0 dt plus the integral of bt to the first power dt. Since a0 and b are constants, they will come across the integral. And now we are going to integrate, which means we add 1 to the power and we divide by that new power. And then we have to add a constant. Now I want you to think about this for a minute. we did not tell you what the initial condition is. But what if I were to plug in a value of 0 for the time? What do we call that velocity? The velocity at time 0 is always called the initial velocity. So if I were to evaluate this at time 0, I need it to equal V0, which means that if I plug in a 0 for t here, I get 0. If I plug in a 0 here for this t, I get 0. So that means that the constant is the initial velocity in this problem, which means that my final equation for the velocity as a function of time will be a0t plus bt squared over 2 plus v0. Do you all follow that logic? Make sense? Any questions, Maddie? I'm still showing all the steps right now to just make sure you understand it.
Can you just, like, which of those steps do you have to show?
Okay, so you have to show this, and then you have to show this. Or sometimes we say, show this and then this. That way you can show how you're evaluating for the constant. Those are the ones you absolutely have to show for credit. Okay? All this middle stuff, no, you don't have to show that. Right now, I'm using the analogy with my Regents kids. I want them to show all of their steps because I said, I need to make sure that you can walk before you run. That's the analogy I'm going to use here. Show me the steps so that way I am sure that you can walk with the calculus before you then just take off and do it. Eventually, by the end of the year, I hope you don't have to show me all the steps. You're going to get comfortable enough doing it. But until you get really comfortable doing it, it's kind of like when you first learned how to manipulate algebraic expressions. For all of you, that was 8th grade when you took Algebra 1, moving things around in Algebra 1. You had to start by showing, okay, first I have to subtract this from both sides, and then I'm going to divide this, and then eventually you just do it all in your head and you get to the answer. Okay, that's the same thing here. Start by showing the steps until you get comfortable with the process, and then you'll get there without. Okay. On the AP, we won't be grading all the middle stuff. We grade the, can you write the statement? Can you show how to solve for the constant? And can you come up with the final expression? Okay. Sometimes they might say just derive an equation for this, but don't solve it, meaning just set it up. You don't actually even have to get to this. They just want to see, can you do this? Can you plug it in and leave it there? Okay. So that's part A. Everybody okay with part A on how to do that integral? Okay. So let's then look at part B. In 124 part B, it says now find the position as a function of time. So to get the position as a function of time, we are going to integrate the velocity with respect to time. So that means I'm going to do the integral of a0 t to the 1 plus b times t squared over 2 plus v0 times t to the 0 with respect to t. Remember, I'm adding that t to the 0 with this constant here because there actually is a time variable there. It's just to the 0 power. Now let's separate it out. So that's the integral of a0 t to the 1 dt plus the integral of b over 2 t squared dt. I'm just also bringing that constant in the front plus v0 t to the 0, that integral dt. All right, let's integrate. So this means it's a0 t squared over 2 plus b over 2 t cubed over 3 plus v0 t to the first over 1 plus some constant. So I got to evaluate for the constant. What do we call your position at time 0? Your position at time 0, the variable is called x0, your initial position. So that means if I were to evaluate this whole thing at a time of 0, it's got to equal x0, which means this is 0, that is 0, that is 0. So the constant is the only thing left. So what does that mean the constant is in this expression? It means it's my initial position, whatever that happens to be. So let's now rewrite this expression. It means that my position as a function of time would be a0 over 2 times t squared. I'm going to combine these constants together. So that's b t cubed over 6 plus v0t plus x0. Does that make sense? Yes? Good? Okay. Now, part C says, find the average velocity over the time interval with an initial time of 0 and an arbitrary final time. So now I want your average velocity, the vector. How do we come up with an average velocity? We do a displacement over the time interval. So the displacement means we're going to look at some position at some time t minus our position at time 0 all over t minus 0. So what is my position at time t? It's that. What is my position at time 0? It's x0. What is the difference in the time? T. So what happens here? This and that will cancel. This time will cancel that. This time will make that a square, and it will make that to the first power, leaving me with an average velocity expression of a0 over 2 times t plus bt squared over 6 plus v0. And that is my average velocity. Displacement over time. Okay? That was part C, right? Yeah. And that's the end of that question. Any other questions? No, we're good? Yes. 121. All right, let's look at 121. Okay, 121 shows you a graph. Position versus time. Okay, you've seen curves like this before. What does that look like? What trig function does that look like, Ruben? That is a sine curve. So this means that x as a function of t is equal to the sine of whatever the time is. It's a sine curve. It's a sine curve. Okay. So now what I want you to do is sketch a rough graph of the velocity and the acceleration. Okay, this is where you might need to use your reference table. How do you go from position to velocity? What's the calculus involved? It's the derivative, right? Okay, use your pink reference table. This means I need to know what is the derivative of a sine curve with respect to time. So look at your calculus expressions. Do you see anything there that says the derivative of a sine? Do you see anything there that talks about the derivative of a sine? What does it say the derivative of the sine is equal to? The cosine. The A is because there's something inside of it. We don't have anything inside. So that means we're going to just drop the A piece. So the derivative of sine is cosine. Okay, do you know how to draw a cosine curve? I hope so. You've seen those before, right? Yes? Okay. Now, how do you go from velocity to acceleration? What's the calculus? You do the derivative of the velocity with respect to time, which means now we need to do the derivative of the cosine with respect to time. Do you see what the derivative of the cosine is equal to? Derivative of cosine is equal to negative sine. So what should it look like? The inverse of what you were given. Roughly, right? If you had graph paper, then you could make sure you were hitting the points correctly and so forth, but that's it. Okay? That one was, if you knew to look here for those calculus things, that's what you have to do, is you have to start down looking here. If you have a function that you've not done a derivative or an integral for, can you read this to figure out how to do the formula for it, to process it? Okay. Anything else? The rest of those problems you were okay with? All right. So for Monday, what am I doing? Alt tab. For Monday, you have to do homework 7, and I want you to read through labs 3 and 4. Homework 7 is the reading guide for chapter 2. And labs 3 and 4 were posted this morning. We're going to be working on them simultaneously. Lab 3 you do with a partner. It's all virtual online. Lab 4, you'll be collecting data in class in a group of 3 or 4. So as, you know, I'll be cycling people through stations. So you're either working on 3 or 4. It takes us 2 days to get all the data for lab 4. Okay, with groups rotating. So we'll talk more about that on Monday. I'm going to stop my recording because I now need to talk to you guys.